chamfer in it. It's also a spacer, so to get the correct space that you want it protruding out of the collet,
Okay.
you use this indent on the back side of the reface tool to set it in correct level. Once that's done, you switch the mode 10 cycles, make sure it's on a short stroke length for the refacing tool. If it's flat, you can put it right over the
And
sample.
that's this in here, this right?
Correct, yeah.
Short is this way, longer is that way.
It's
right?
all up here,
Okay.
as far as you can see the orientation of the retaining bolts, and we're set at 1 inch right now, so it's at that position.
Okay.
And that's what you want to be at for this refacing tool.
Now, do we need to do this before we start every time?
Typically, it's good practice to do it before every test.
Okay.
And if your braiding gets clogged, which it may not, it may just break down as a test, which is fine too. But some materials will clog up, and it requires refacing in the middle of the test. But to get a fresh, even surface on it, it's a good idea to reface it before the test at least.
Okay.
Ideally, you probably want to clamp it down. Hold it firmly as well. But if it's on a flat surface, it should work all right. And you just go ahead and hit start. Typically, refacing is about 10 cycles with the base load. You can see the material, the wear acer comes off onto the refacing tool, and now you have a flat surface under there. And these divots here are chamfer, I guess a way to cause a chamfer. So you just do this. Think about the manual specifies 3 half turns.
Okay.
So a few times in the chamfer divot, and it'll put a nice chamfer on there so it doesn't dig into the samples it's testing with a sharp edge.
Gotcha.
Once you do that, now you have a uniform surface to test with. And then we'll probably go measure this for weight to get an initial reading and a
Okay.
final reading.
Okay.
Just to give an idea.
So we're going to need to know the weight of our material.
That's typically how we do. Sorry, I just grabbed your pen.
Sorry.
Typically, how we do abrasion. Measure the abrasion resistance as mass loss.
Okay. Whatever photos you took. I'll have you email them to me too.
Okay.
So just for just to get a general idea, I started with one 250 auxiliary weight, so it's going to be 350, 450, 500 grams. The mode goes back to test.
And we're on
And-
60, right?
Yep, 60 cycles per minute, which I guess we'll start with that. We can start with 50 cycles and see what happens here. Another thing to consider is just be careful of the edge of the product like this. You don't want it to have it to traverse off and then try to traverse back as it falls off the lip.
Okay.
So to check that, you just kind of want to make sure this is in the center. To do that, you can close the lid and hit this aux button here.
Mm-hmm.
It'll traverse it slowly. Hit it again, and now it's up and down, which means it's about the center of the stroke.
Okay.
So you want to adjust the wheel or your test sample so that it's in the center of the wear path there. And I have it set to about 1 inch, so it'll go a 1/2 inch each direction. So it should be okay. But in case, we'll slow it down there for 40. And let's as Alan mentioned, there are particles in that material, so your braiding's wearing down
Quickly.
quickly right now. And that's something to keep in mind because it's going to wear down and you don't want to allow it to contract it.
Yeah.
So it may be necessary to stop the test early. So I'm going to go ahead and stop it at 25 cycles. And then this is another item that comes with the kit.
Well, we have that.
Do you?
Yes,
Good.
we do.
So you have a bunch of abradient material there. I'm going to brush that off. It's just, I mean, with whatever method you come up with, it's good just to be consistent. So if you decide to brush off your samples, just make sure you do it every time when you're comparing
Same
Okay.
time.
your samples of your test.
And then you reweigh it again after the test?
Yeah, and so I did 25 cycles there, so I don't expect hardly any mass loss. We did get about 0.02 grams, which isn't a whole lot, but it's actually more than I expected. So.
Okay.
And with this, obviously, it's wearing the abradant so quickly that I'm not going to bother refacing it because it means it's not clogged. So if you loosen it up, kind of pull it out, and then readjust this. Now it's set at the correct extruding length. I forget what the length is. It's listed in the manual.
Okay.
Move it over again. And I stopped it at 25, so I'm just gonna hit start again. Stop it. For something like this, it's not really a precise test because I've moved it, so it's not off of the same wear path now. It's not wearing on the same path. So just for demonstration purposes, but ideally you want to get it set up so that you can replace it, put it back in the same spot and continue the test.
Gotcha. Now, what is this actually, like, checking?
So what you're doing is you're I guess allowing a way to measure the resistance of wear on the material. So what you'll do is you'll weigh it initially, get the initial mass, you'll braid it for so many cycles, and then weigh it at the final. And that difference will give you your quantifiable data to allow you to I guess measure or get an idea of what your abrasion rate is going to be. So you can use that as a standard. If you perform so many tests where you get, okay, this is the average mass loss that we're seeing with 100 cycles, then you can use that as your standard and say, well, this is what our material is capable of withstanding. You know, this type of mass loss with this type of abrasion. And if you get a product that falls below that, then you may want to tweak it so that it's at least measures up to what your standard is or exceeds that.
So that's what we need to do. We need to create a standard.
Exactly. Come up with. I think that's what Alan was trying to explain.
Yeah.
Is come up with some type of sort of a baseline using this instrument. Just test your products that you have out right now, and just come up with a general, test procedure, so that you can perform the same test every time
And qualify it from
and
there.
then use that as your qualifying, and use that for your baseline to compare with something that you may do in the future. Tell you how much wear you're going to see, and I've got 0.3561 grams initially. I wore it for 25 cycles. Now we're down to 0.3318 grams. So that difference here is going to be your mass loss, and you can quantify that as your abrasion rate. And then from 25 to 50, whatever that mass loss from 3318 to 3064, you can use that to say, okay, well, this was about the same from initial to 25 or from 25 to 50, and you could keep going and graph that, and hopefully you'd like to see kind of similar. It may go up and down because of variation, you can't avoid that, but ideally when you average that all together or take the total and then compare it with the second test, you should, with the same material, same test setup, you should see the similar results.
Okay.
And then that way you can quantify, this is the type of abrasion that we would like to see in our product, because that's what we, our current product,
Gotcha.
Just-
Do you understand that?
to
Okay.
get an idea of just how this machine is, because you haven't used this before to test your product. So to correlate what you know and what your current product is, you just want to start running tests and come up with a procedure that gives you good, consistent data. And then with your current product, once you have that, then you can use that data to compare it with maybe new product development or just quality control. Just make sure that every so many lots of this material that you're getting that same data. You know what I mean?
Yeah. Now,
There's
can
a
this
variety of
machine,
things to use.
does it have to be in a climate controlled area?
Does
like
it work
to see
best
that.
there?
It works best because then you know that every time, whether it's winter or summer,
It's going to stay the same.
you're under the same conditions.
To be consistent.
That's the whole goal. Is
Yeah.
to be
'Cause I wanted to put it in
as
his
possible.
area because he would be using it more, but it is a dust-filled area,
Yeah,
so it's probably not so good for this either,
You
right?
could cover it, but I mean,
yeah. I mean,
I guess we'll have to leave him there. You'll have to walk back and forth.
that's no big deal.
Yeah.
That's no big
yeah.
deal.
I mean, that's the thing, is just consistency. The more consistent you can keep everything, the
Better data you're gonna have
because
too, yeah.
The more consistent data is going to have. So.
All right. Makes sense.
So that's just an example of, and you can pull out your calculator and find the difference there and figure what that's going to be. But that's one option. That H18 wore down pretty quickly, as you saw. So maybe it would be maybe a better idea to use an H22, which is the more aggressive wear acer. We could try that. These are pretty beat up. I have to reface this one.
Because
Now, what we're going to be using is obviously the whole OD it's round. It's
Okay.
a bar.
Right.
Now, how would you clamp that down? Is there an
Um,
attachment for that?
Depending on the size,
3/8
we offer this hold down plate. I don't know if it would be beneficial to set it on top so that it
so
kind
you-
of
yeah,
holds
it would
it,
just groove in there, yeah.
or maybe set it on the top of it. I mean, like I said, it depends on the size. Like something like this is not going to retain it. You could potentially put a piece of tape in here so that it could hold something this small. You know what I mean, kind of be creative and come up with
So
a
we
fixture
can come
to
up
hold
with
it.
ways to do it as long
Sure.
as we can plan. We want to keep it still.
Sure.
Okay.
No, absolutely. So that's one of the accessories we offer. It's I think it's called a hold down plate or a narrow. There's the wide, which you saw in there, and then the regular one that I showed you.
You can make something too, so add to that.
Yep. I mean, that's what's nice about this T-slot table is it allows you to use stuff like that.
I'm
or
pretty
something
sure
that
we
you
have the
might
table.
Absolutely.
make to kind of secure it in here
Right.
with standard hardware like this, pretty standard. So, like, yeah. So the H22 is a little bit more aggressive. I'm gonna try that. Space it out. Tighten it up. Just use this to reface. Actually, let me go mode.
You can hear the difference
Yep,
of the abrasion.
of course. And it's not a bad idea to look at it, just check it. I mean, the manual recommends 10 cycles. If you see that it's still beat up from the previous test, it may be ideal to run it, for 10 more cycles to get it flat so that it's consistent.
Okay.
For time's sake, I'll just excuse me, leave it like that. We'll do 25. You can already tell that it's not wearing the braiding isn't wearing away as quickly.
Yeah.
So maybe the H22 would be a better option for
That ceramic's hard. You know, yeah.
Yep.
All diamond tooling, to cut it, do whatever we have to do with it.
So there's 25. Probably could have gone longer, but actually this time you can see the material from the ceramic wheel itself came off this time more than the abrasion.
Oh,
So
yeah.
that's what you want.
That's what we want to see.
So
Okay.
maybe H22 be a good option to try
Okay.
out. You can actually see the wear groove in the wheel this time.
So we should get a little scale. I don't know if we have one. Do we have one?
I have one.
You do?
Yeah, a gram scale.
Okay.
This one's
That's gonna be a pain for you to carry it back and forth though every time you set it up.
No, it's not that big.
You know, don't you have to like level it every time?
No.
You don't have to level your scale. Does this one have to be leveled?
yeah. Typically the
Yeah, so
scale.
you
This does.
You don't have that
It's
on
not
yours?
like this, no.
What do you have? What kind do you have?
I don't,
I'll
what
have to
kind
take
it
a
is. We'll
look
look
at
at
it.
it. If it's not up to
And
snuff, or then we'll have to
does it
get
ever
one.
get calibrated?
No.
All right, we need to start.
It's
getting
just for weight, for weighing the ceramic. It isn't.
Well, if
it
we're gonna
isn't-
be using it for measuring,
Yeah.
we need to get it
Might be
calibrated.
worthwhile to get a decent scale. Some of them,
Right, you can get one.
it would be good to at least get out a readout to 3 decimal places for the gram measurement.
Right.
This one obviously goes out to 4, but you're going to pay quite a bit for something like that.
Yep.
It may be more economical to at least get one that reads out 3.
3, okay.
That's pretty accurate. Down to 1 milligram is a lot of test standards require down to at least a milligram.
I think we can run them too. I don't know what the better option would be, but if we run them from a place, they come out and calibrate them every quarter of the year, I think, or
whatever,
something like that.
Okay.
whatever works.
Yeah.
Yeah.
So yeah, if you can't level yours and know where it's level, I'm not too confident that it's.
Yeah, I don't do those kind of tests.
Yeah.
I just, in a way, like, like the
Yeah,
ceramic.
we'll need something that's going to be more accurate.
It's only a
probably.
two-place, too. Mine's only a two-place.
Oh, okay, yeah, no.
No.
Yeah, so this 25 cycles with the H18 dropped at about 0.025. And then here you get a difference of 0.06. So it's quite a bit more wear, and you can even see the indentation from,
Oh, yeah, yeah.
from the H18. Now, like I said, I didn't reface it probably as much as I should have, so it's probably a little bit rougher. But and you can see the indent of the roughness of this.
Right.
But ideally, you leave it nice and refaced so you get consistent data every time. Because if you just that's like an example. If you run this again and reface it, now it's flat, then the next wear path or wear cycle would be different probably because I didn't reface it enough the first time. So
Right.
that's an example of something you want to keep in mind to make sure you're being consistent every test that you run.
Okay.
So I think that could be an option for you, the H22. As far as using your ceramic to abrade a surface, you could use something like this. Alan came up with a way to secure this using a longer bolt, but like he said, there's different options that we can hopefully come up with to test your product. So just Allen wrench removes the collet, the collet comes off, and then put on different attachments such as this knuckle that he had mentioned. Let's see, this has got a little guy. Which size that is. Square. It's kind of holding it. View is, excuse me, option tests for people who are looking for different ways to test things. So a lot of times we're coming up with ways to test different things that we've never tested before.
Okay.
So this
Well,
is
that's good to know. We can let Tom know that too.
Yeah.
'Cause he's,
And yeah, if you wanna send us some samples, maybe we can come up with a way to test your product and say,
We could do that. Yeah.
you know, hey, we found this works well.
Okay.
This tested
Yeah.
this product.
all right. As soon as you get some, maybe
That's
we
far.
can
Yeah.
do that.
Yeah.
Okay.
That's far.
And we can do that for you.
Just email you.
Yep.
Okay.
Awesome.
Yep.
Awesome.
Speaking of which, before I forget,
Oh, yeah.
I'll give you both.
Oh, thank you.
Thank
Yeah.
you.
Right.
I'll show you mine too.
Absolutely.
I think I have one here.
Now in this case, the laser's not going to work. Thank you.
Mhm.
This isn't really. That's good enough.
So again, just another way to test the same material in a different fashion. This time we're using the material itself as the moving item, but the abrading is a fixed piece of sandpaper strip. This sandpaper typically used to reface the CS type wear erasers, the soft style, which is probably not what you're going to use, but that's what you use to reface those. So we just run that. Actually, you know what? I never measured the weight, so let me do that before I grade it. just to get an idea of what happens.
So yeah, all different kinds of razor machines. Huh?
Oh yeah, those are our rotaries. That's our dual model for customers that run tests very often.
Yeah.
They can run two at once, which is nice.
Oh.
But this instrument we use, it meets a lot of standards. There's a few ASTM standards that call out for that instrument. There's ISO methods that call out for an instrument that is similar to this, that this can meet. So it's very, very common instrument to test for abrasion. How it works is actually these types of wheels. Let me just grab this measurement quick.
Okay.
This is unique, so this isn't our typical wheel, but they fit on like this, and you'd have two. You'd mount your specimen on the turntable, and then you lower these down, and these wheels that are lowered down are off axis, so they actually get kind of a rub wear abrasion action, and it creates a crosshatch pattern and a circular pattern in the sample.
Okay.
And then same concept. You weigh it before, you grade it for so many cycles, then you weigh it after, record the mass loss, determine the abrasion rate via mass loss that way.
Interesting.
This instrument is, a lot different, but essentially the same concept. You want to get an idea of the abrasion rate using mass loss. This is more versatile for product like what you're testing, because it sounds like your product is going to be almost like a round.
Yeah.
So obviously you wouldn't be able to use the
Right.
rotary to test something like that. I just 25 cycles. First layer so that you know it's connected. Once that happens, then you record the mass loss. That way, your initial mass loss is going to be different from the sequential mass loss readings.
Okay.
So let's take that off and measure it.
So basically, the lighter this is, it depends on how many of these you're going to
Exactly,
use.
yeah.
Yeah, I don't
So
know.
if you wanted to accelerate the wear, you could stack the weights on.
Put more pressure on it.
Exactly, which puts more pressure on it. And finding it like this, that accelerated the wear quite a bit.
Okay.
So the type of abrading we use and the load all influences that. And just to be consistent in the pressure. So that lost about 0.02, 20 milligrams. Similar to the CS, or the H18 rather. So let's see. Show you the scratch. is another attachment here. It's scratch tip attachment. Can accommodate various scratch tips. This one's conical. It looks to be about 90 degree, maybe 90 degree conical scratch tip. I'm going to use this one because it's damaged. And when you're testing, ideally you don't want to use one that's damaged.
Yeah,
But because
exactly.
we're doing
This is just a demonstration. Yeah.
on pretty aggressive
Okay.
wheels here, I'm going to use the damaged one. But something to keep in mind too. You can see for yourself. If you look at this closely, you almost have to touch the plastic. You can look at the tip, and you can see that if there's a chunk taken out of it. You gotta get real close.
Oh yeah, I see it.
Yep.
Yep. Oh yeah.
Because otherwise you'd hardly
No.
be able to
No.
see that it was damaged.
Okay.
This is one of our accessories too
Oh, that's an accessory for this?
for
Get it,
analyzing.
it's good to have. Or we can put it on the comparator and pick it up that way too.
Sure.
Alright. So, I'll use this one again. Make sure that it's the same. For a scratch test, it may not be as bad.